What if I told you there is a rule that says you can never have it all? No matter how smart you are, no matter how much money or resources you throw at the problem, you will still be forced to compromise. This is the CAP theorem, and it is the reason why even billion-dollar companies have to make sacrifices in their tech. By the end of this video, you will have a fair understanding on what consistency and availability are, and how do you make the trade-off between consistency and availability in distributed systems. So let's see this with the help of an example. Let's take an example. Let's say you have an online store which is more like an e-commerce. So you have this e-commerce platform, and to begin with, you are keeping things simple, and you have a server located in New York. So New York is somewhere here. So whenever someone accesses your website, he will have to connect to the server located here in New York. So you have everything in New York, all your servers and data centers. So it sounds like a good idea, right? So anyone using your platform will have to connect to the New York server. So let's say someone from US wants to connect, they will send data to the New York server and get some response. Similarly, someone connecting from London or UK will need to communicate with the New York server and they get some response. Similarly, someone in India can also connect to the New York server, and same with Japan also. Someone in Japan will also have to connect to the New York server. So here's the problem. People staying in any part of the world have to send their traffic all the way to New York to get data. For people living in the US, it's fine. But for someone living in India or Japan, they will face a lot of latency in their requests, since for them data will pass through so many different routes to reach the New York data center. So this is one disadvantage of having only one server if you have customers all over the globe. In short, having one server will increase latency. Now what if this server fails? In that case, no one will be able to access your e-commerce platform. The site will be down for everyone. Having one server also introduces a single point of failure. Also, let's assume the number of users across the globe increases. So there is someone from different parts of Africa or South America or Australia. They all connect to this one server based out of New York. So the load on your New York server increases. As a result, you decide to upgrade this server. But there's so much that you can upgrade. There will be a hardware limit on which you can vertically scale your server. After the point, you have to increase the number of servers to serve the load across the globe. So vertical scaling is not an option when you want to scale your system. I have made a separate video on horizontal scaling and vertical scaling. Make sure to check it out. It will be visible in the I button at the top. So to solve all these problems, you decide to introduce more number of servers across the globe. So you can put one server in, let's say, London and one in New Delhi. So now people in America can connect to the New York server. People in UK no longer need to connect to the New York server. They can connect to the server in London. Similarly, people in Asia can connect to the server located in New Delhi. Now you no longer have this problem of latency because people are able to connect to the nearest server. So this latency problem is resolved. You no longer have a single point of failure because let's say for some reason the New York server is down. These people can connect to the next nearest server, which is the London server for these people, or the New Delhi server in case the London server is down. So the problem of single point of failure is also solved, and you horizontally scaled your servers, as in you increased the number of servers across the globe. So you no longer have a hardware limit on vertical scaling because you don't need it. This is the reason why if you have customers all across the globe and if you have large number of people using your system, you scale out your system. You increase the number of servers. Increasing the number of servers also comes with its own challenges. You need to maintain consistency of data across all the servers. You also need to maintain availability. You want your servers to be up all the time, so availability is also one factor. Let's see the problem of consistency and availability with the help of an example. Let's say someone named Sarah in US buys an iPhone from your e-commerce platform. The catch is you had only one iPhone in stock. Now all your servers across the globe show that your remaining number of iPhones is 1. Now Sarah from New York purchases this iPhone. So the New York center now shows that there are 0 iPhones. But let's say Gourav from India, he also wants to purchase the iPhone, and he sees that the count in the New Delhi server shows that it has one iPhone remaining. So he also goes ahead and makes the purchase. So the problem is you oversell your iPhones. So you had only one iPhone in stock, but since there was no proper data sync between your New York server and New Delhi server, you oversold your iPhone, and this is a big problem. Data sync. Whenever any change is made in the New York data center, it should immediately reflect in all the other servers across the globe. And in technical terms, this is called consistency. Your data needs to be consistent across all the systems. So to solve this problem, you need data to be communicated quickly among all the servers. So as soon as data was changed in New York, it should reflect in the New Delhi server. But the problem is data takes some time to travel between two servers. So we call that there is a partition between these two servers. And we need our system to be partition tolerant, which means even if it takes time to transfer data, it should be working. And this is called partition tolerance. And these are the basic principles for CAP theorem. So C in CAP theorem stands for consistency, A stands for availability, and P stands for partition tolerance. So these make up the CAP theorem. The CAP theorem states that in any distributed system, you can have any two out of consistency, availability, and partition. So let's look at this with the help of examples. Let's see why all the three are not possible. If the system were to be consistent, so when Sarah sees that only one iPhone is left in stock, Gourav at that same time when he requests for data, he should see that there are 0 iPhones remaining because Sarah in New York already purchased that last iPhone. So if my system were to be consistent, this should be the behavior. Now availability means the system should always be accessible. There should be no downtime or close to 0 downtime. Availability means no matter how much traffic you get, your system should always be up and running. So when Gourav from New Delhi requests some data, he always gets it. That is about availability. Partition means the connection between the servers. So there's a partition between two servers, and that is called partition. Partition tolerance means in the event that the London server is down and the partition breaks, is your rest of the system able to handle data smoothly? Is it able to function smoothly? That is called partition tolerance. As per CAP theorem, we can't have all the three elements. So now let's look at each of these combinations. So first let's talk about a CA system. So CA system means you focus on consistency and availability. You don't want your system to be partition tolerant. Well, in real world, in distributed systems, you actually need your systems to be partition tolerant, which means if a server goes down and if there is a breakdown in the connection between two nodes, you want your system to be working. CA is something that we don't pursue on in real world, so your systems can't be CA. Well, in case if you have a single node working, in that case you can prioritize on consistency and availability, because if you have one node, you don't need your systems to be partition tolerant because there is no partition. So in the example, when we only had a server in New York, you can make that system CA, but if you have multiple nodes in your system, you don't want it to be a CA system. So CA system means data is consistent across nodes and your data is available, and as soon as you write data in one of the nodes, it is immediately reflected in the other node. So but that is not possible also because data will take some time to travel. Hence, we can't have a CA system with distributed systems. So whenever trying to design a large scale distributed system, this is not an option. Now let's move on to the next, which is an AP system. AP stands for availability and partition tolerance. So AP system means you want your system to be highly available and partition tolerant. So it means even if some of the servers are down, you want your system to function smoothly and you don't care of data consistency. You are okay with data inconsistency. So in the example, you are okay if Sarah in New York purchased the iPhone and the iPhone count went down to 0, but you are fine if Gourav in India sees that the iPhone count is 1, because data will take some time to sync. So when data is updated in the New York data center, it will take some time to reflect in the other servers. You are okay with that. You don't want data to be consistent immediately across all the servers. So that is what availability and partition tolerance is all about. To summarize, in AP type of system, your servers are always online. Even if there is a partition between two servers, they keep on functioning properly, and eventually data is synced when they can recommunicate, or data can be synced after every certain intervals of time. You can have eventual consistency in AP type of systems, but you can't have real-time consistency. So this is a trade-off which you need to make while designing large-scale distributed systems. Now let's see a CP type of system. CP type of systems, they prioritize consistency over availability. In CP type of system, your servers will go offline till all the data is synced across all the servers. What this means is, if Sarah in New York purchases the last iPhone, now Sarah purchases, so the iPhone count goes to 0. So the system will stop working, like it will go offline for some time till data is synced across all the other servers in the globe. So until the New Delhi server syncs this iPhone count to 0, Gourav in India will not be able to access the e-commerce platform because the system is down to allow data to sync. So in this type of case, we call it a consistent system which is not highly available. So in short, in CP type of system, data is synced by each server going offline, and hence we compromise on availability in this type of systems. Talking about real world examples, how do online stores handle the CAP theorem? Like, what do they prioritize? Do they have a AP type of system or CP type of system? So most big online stores like Amazon actually prioritize availability over consistency. They need to keep the site running even if there are some lag in data updates across the servers. That's why sometimes you see an item available, but when you try to check out, it disappears. It's a CAP theorem trade-off. They want users to have a good user experience, so they prioritize availability. Especially in times like Black Friday sale, it is more important for your site to stay up and handle massive amount of traffic than it is to instantly update every customer with the most accurate stock levels. This was all about CAP theorem and it's a wrap. So the CAP theorem teaches us that when you are building systems across the globe, you can't have it all. You have to decide what's more important for your business, keeping your site always available and ensuring everyone sees the same data, or handling server failures. So next time you are frustrated with a site glitch or out of sync stock, remember, behind the scenes, engineers are constantly making tough trade-offs with the CAP theorem in mind. So by the way, what would you choose if you were running an online store? Consistency, availability, or partition tolerance? Let me know in the comments below. And if you enjoyed this breakdown of the CAP theorem, don't forget to subscribe for more tech insights and system design stories. Till then, happy coding. Bye bye.